So in this video, all I'm going to do is work through the solutions to section 3.1, page 171. This is 171, it's not absolute value of 7. And then this is number 25 and number 31. So I'm just going to work through those. They're pretty straightforward. They shouldn't take a whole lot of commentary, so I'll just work through these. This should, I hope, be fairly quickly here. So number 25. Again, what we're doing is finding the absolute, max, and the absolute min for the functions on the interval. So we'll have to be given a closed interval here. Number 25, we have h of x is given to be 5 minus 2x to the second on the interval from -3 to 1. All right? So we're going to do the process. This is straightforward. We're going to find the derivative. The derivative here is -4x. I'm going to find the critical values. Type 1. That's where the derivative is equal to 0. And so we're going to set -4x is equal to 0, which gives us x is equal to 0. So that's type 1 critical value. Type 2, I'll do this down here. Type 2 critical value. That's where the derivative does not exist. But since the derivative is a polynomial, that means there are none because it's a polynomial. So anytime the derivative is a polynomial, there are none. Because it's a polynomial, make sure you write there are none. Make sure you write it's because it's a polynomial. All right? So now we got to find h of and round up the usual suspects. We have to do endpoint number 1. We have to do endpoint number 2. And then all the critical values we found, which are right there, 0. So, h, this is the original function. This is 5 minus 2 times -3 squared, which is 5 minus, what is that? 9 times 2 is 18. It's -13. H of 1 is 5 minus 2 times 1 squared, which is 5 minus 2, which is 3. I can do that. And 0, I should be able to handle that. That's going to be 5 minus 2 times 0 squared, which is 5. And so we need to pick the big one, pick the little one. So the absolute max is at, the big one is here, that's 0, 5. And the minimum is -13, so that's at -3, -13. And they'll be banging car doors in the streets tonight. So that's pretty straightforward. And then we'll continue on here with number 31. So what we have here with number 31. All right. All right, so what's my function here? This is g of x this time is equal to, I have 6x to the second over x minus 2 on the interval -2 to 1. Does that look right? All right, pot looks right. So now we need to do the derivative. That's denominator times the derivative of the numerator, which is 12x, minus the numerator, times the derivative of the denominator, which is just 1, all over denominator squared. And I think if you simplify, this becomes 12x squared, minus this becomes 24x. This is minus 6x squared. And at long last, that simplifies, those cancel. So that's not cancel, but those reduce. That's 6x to the second minus 24x. And then that's all over x minus 2 quantity squared. So I think that's my derivative. Good old quotient rule, and simplify enough that we can solve this thing. All right? And so now we're going to find the critical values. Type 1. That's where g prime is equal to 0. Fraction equals 0 means that's where the numerator, 6x to the second minus 24x is equal to 0. Factor out 6x, leaving behind x minus 4. And so we get, I'm going to run out of space here. We get x equals 0, and we get x equals, what's the other one, 4. So those are my two type 1 critical values. Type 2, that's where the derivative does not exist. And that's where the denominator is equal to 0. And it's not very hard to see. That gives us x is equal to 2. So we have 0 and 4 and 2, and we have negative 2 and 1, and some of those probably don't pass muster. 4 is no good because 4 is outside the range we're looking for. So 4 is out. 0 is good to go. 2 is out. We're not allowed to use 2. That's outside the interval we're playing with. And so round up the usual suspects. We need g of endpoint number 1. We need g of endpoint number 2. And we need g of the only critical value that survived muster was 0. All right? So the only critical, in this case 4 was outside the interval. 2 was outside the interval, so those get crossed off. And it's back to the original function. And not much left here. It's going to be all over but the shouting. So we need g of negative 2. So this original function here. So this is 6 times negative 2 squared over negative 2 minus 2. Which is 6 times 4, well, 6 times 4 is 24, over negative 2, negative 2. Negative 2 minus 2 is negative 4, plus negative 6. All right, so I think I got my negative 6, that's the number I got. And let's see, then g of 1, this is 6 times 1 squared over 1 minus 2. So that's 6 over negative 1 is negative 6. So I got negative 6, I got negative 6 again. And then g of 0, this is 6 times 0 squared over 0 minus 2. And that works out to be 0. So the big one is 0, and the two little ones both tie at negative 6. So we have absolute max at 0, 0. We have absolute minimum at, let's see, at both of these, we have to list both, negative 2, negative 6. And the other one is at 1, negative 6. All right. And so that's all there is to that. So there's 31 also worked out. Again, watch out for the ones that don't pass muster. And if you have repeats, you list them both. Make sure you do the arithmetic correctly.